Hi, I'm Paul Rothrock, a solution engineer here at pgEdge. pgEdge platform can give fully distributed Postgres for high availability with low latency, but first you need to install it. In this video, I'll show you two ways to install pgEdge platform on your Linux servers. First, I'll go through the manual setup process to give you an overview of how a pgEdge cluster is set up, and then I'll show you how to use our CLI tool to deploy a cluster automatically from a JSON file. This is going to be a simple two-node setup, but pgEdge can be scaled to more servers to suit your uptime and performance requirements. Before using pgEdge, you'll need to prepare your servers. First, make sure you're running a supported Linux distribution and Python version as listed on this slide. Next, make sure your servers are set up for pgEdge. Open any firewalls between the servers, configure SE Linux to permissive or disabled, ensure you have password-free SSH for the server by setting up an SSH key, and finally configure a password-free sudo for that SSH user. Instructions for doing these are available in our documentation. Once that's all done, we can install pgEdge. First, I'll show you how to set up a cluster manually. Each of these terminal windows is logged into one of the nodes of my cluster. The first step is to download and run the pgEdge installation script on both systems. Note that you don't need to be a super user to install pgEdge. This will install it in a directory named pgEdge. Next, run the setup command on both systems. This will install Postgres, the Spock extension, and create an admin user and a database. The next step is to create a node on each machine. This will let other machines in the cluster know how to connect. On each system, we create the node specifying its name, the data source name or DSN used to connect to the server, and the database to use. The DSN usually contains the hostname or IP address of the server, the user you connect as, and the database to connect to. The username will be the same user you installed pgEdge as, in this case, Ubuntu. Now you've got two pgEdge nodes ready to hook together with subscriptions. Each pgEdge node needs a subscription to the other so that data is replicated between them. So on the first node, create a subscription to the second, and on the second, create a subscription to the first. Each subscription is given a name and the DSN for the other server, as well as the database name. One thing pgEdge does for you on installation is to create an environment file with variables to make connecting easier. So on each node, we source that file and we can connect to the database. It's good to add this command at the beginning of your .bashrc file to ensure they're set when you log in. Next, we'll install the pgBench test database on each server. Finally, we'll set some columns to use pgEdge's delta apply feature. Normally, pgEdge uses the last write to determine the final value of a column, but some columns, like account balances or inventory, need to have all updates applied in order to make sure they're accurate. So on each machine, we'll set the balance columns for the pgBench database to use this, as well as log the old value when this happens for auditing. Also, while pgEdge is native Postgres, there are some schema considerations for logical replication. Namely, every table needs a primary key that is guaranteed to be unique. In this case, the pgBench history table doesn't have one, so I'll add one and set it up to use a snowflake sequence for uniqueness. Then we'll repeat these operations on the other server. With that done, we can use the pgEdge CLI to add the pgBench tables to the default replication set. And we're done. Now if we update some data on one node, it's replicated to the other, and vice versa. Another way to set up a pgEdge cluster is to use our JSON cluster deployment method to do a lot of the work for you. As with a manual installation, start by downloading and running the pgEdge installer script, but this time you only do it on one node. You could also do this from a separate machine. The next step is to create a JSON file like the one on the right side of my screen. Full specifications are available in our docs, but this command will create a template clustered JSON file for you. That creates the file in the appropriate directory so that you can fill it in. I've already got one prepared, so let's use that one. As you can see, this file includes parameters like the Postgres version, the Spock plugin version, databases and users to be created, and the nodes in the cluster. Also, this file enables pgEdge's auto DDL replication, so changes to the schema are replicated. Once your file has the right configuration, setting up your pgEdge cluster is just one command. The pgEdge CLI will go through the steps of installing Postgres, the Spock extension, creating the nodes and subscriptions between them, and adding the database to the replication set, and it will do this on both nodes at the same time. Once that's done, we can install the pgBench test database, and since the cluster is set up with auto DDL, it will be replicated to the other node. Then you can alter the tables to include delta apply and add a primary key, and you're ready to go. As before, DDL statements are automatically replicated across the cluster. And now we can test the replication. As you can see, pgEdge is pretty easy to get up and running manually, and the JSON cluster setup makes that even easier. Both are great ways to try pgEdge out for yourself. There's a lot more to pgEdge, so be sure to subscribe for more how-to videos, hit the like button if you learned something, and let me know in the comments if there's anything specific you want to explore. Thanks for watching.